Hello guys, in the previous video I derived the ideal gas equation and I told you about Boyle's law, Charles' law and Avogadro's law. Those are the ideal gas laws. However, I also told you that you do not have to memorize those. It's enough to know the ideal gas equation. So let's use that and look at a couple of examples. How can you derive any of the gas laws? In the first sample question, we have a gas, 2 moles of it, at 5 atm pressure, and it is expanded at constant temperature from 10 liters to 25 liters. We have to calculate the final pressure in atm using Boyle's law. So let's assume that we don't know Boyle's law, we only have the ideal gas equation right now. Now, what happens in this question? Let's try to analyze it. We know that we have a constant number of mole of gas, right? And we also know that we had an expansion, so the volume increased from 10 liters to 25 liters. So let's use balloons to show that. So let's say that I have a balloon and this is going to have a volume of 10 liters and another balloon which is going to have a volume of 25 liters. Now I know that my initial pressure was 5 atm and I have to calculate the pressure after the expansion. Let's start with the ideal gas equation. So we know that the number of moles is a constant. We also know that R is the gas constant, it's in its name, and T the temperature, which is also constant. So basically, when I go from the first state where I have V1 and P1, I'm going to end up in a second state where I know V2 and I have to calculate P2. Now, because nRT is a constant, I can rewrite this expression like so. P1 multiplied by V1, right, this part of the ideal gas law, equals nRT, which is a constant in this case, which should equal to P2 times V2 because the number of moles, the R, and the temperature did not change during the expansion process. So now I simply just have to solve this expression for P2. Okay, so P2 equals P1 times V1 divided by V2. Now I just have to plug in the values. So P1 is 5 atm. I have to multiply it by the first volume, 10 liters, and divide it by 25 liters. Let's check the units. Liters cancel out. My final unit will be atm. And if you do this calculation, you are going to get 2 atm. All right. I hope this makes sense. Let's take a look at another example. A balloon is filled to a volume of 15.4 liters at 25 degrees Celsius. What will be the volume of the balloon if the temperature of the gas lowered to 125 Kelvin? Okay, so let's try to imagine what happened here. We have a change in volume and a change in temperature. So if we start with a balloon that is 15.4 liters at 25 degrees Celsius, we are going to end up with a bigger or a smaller balloon if we go down with the temperature. We're going to end up with a smaller balloon, right? So in this case, we don't know the volume, but we know that it is 125 Kelvin, the temperature. Okay, so if we look at the ideal gas equation, we know that the pressure is constant, R is constant, and N is constant. So let's rearrange it and have all the constants on one side and all the variables that are changing on the other side. So basically, I'm going to divide both sides by the temperature, so V over T, and also by the pressure equals nR over P. So remember that this is going to be constant. And because only the volume and the temperature are changing, I can say that V1 T1 equals V2 T2. And in this case, 15.4 liters is my V1. My T1 is 25 Celsius. I don't know my V2, but I know my T2. Okay, so I have to solve for V2. So from here, from this expression right here, I know that V2 actually equals V1 multiplied by T2 divided by T1. Now, let's check our units. Do we need to convert anything? We do, right? Because we have Kelvin temperatures and Celsius temperatures. So we have to convert 25 degrees Celsius into Kelvin, for example. So here, T1 equals 25 plus 273 kelvins, which is going to give us 296 kelvins. And that is my temperature. And now I can simply plug in the values. So 15.4 liters multiplied by 125 Kelvin divided by 296 Kelvin. And let's check the units. Kelvins will cancel out. My final unit is going to be liters. And if you do this calculation, you are going to get 6.4 liters. Okay, is there any other law that you could have used in order to solve this? Yes, there is. You could actually use Charles' law to solve this question. However, we didn't need it because we had the ideal gas law. Okay, so we can come up with a so-called combined gas law. And this is from the ideal gas equation. If the pressure, volume, and temperature are changing and the number of moles is constant, we can rearrange the ideal gas equation. So this is constant and this is constant. So nR will be on one side and PV and T on the other side. So in order to get there, I have to divide both sides by the temperature, right? So P times V over T is going to equal to nR. And if I have a change, I can rewrite this as P1 times V1 over T1 equals to P2 V2 over T2, just because N times R is always a constant. All right, I hope this makes sense. See you in the next video.